We're going to try something new today. I'm going to just try doing a little bit of a lecture and posting it for you guys to look at before we start on class. So as you can see, I took some notes here today, and I want to show you guys some things about EKGs just to refresh your memory. So to start with, the EKG waveform, the one that we see in many, many bad tattoos, and the one that we are looking at here is right here. So there's different parts to what we call the waveform. So there's that first little bump, which is the P wave, the QRS, which is the spiky one, and the T wave. What those things represent is P wave, that first little bump, is your atrial contraction. You may remember from your basic anatomy that the heart has a pump on the top and a pump on the bottom, right? And so the top is called the atrium and the bottom is called the ventricle. And it goes dun, 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 right? So the P wave is that atrium contracting. It's pretty small. The atrium is a thin wall. It's not nearly as muscular as the ventricle. The QRS, you see right here, right there, that's an arrow, not a V. I'm just realizing now that that probably looks like the letter V. It is indeed not the letter V. It is a QRS complex. So the QRS is what it looks like when the ventricle is contracting. Very different, right? Two parts of the same heart. One is a tiny little blip and one is a big electrical event. And that is to do with the amount of muscle that is in the ventricles. The ventricles are sending blood to the entire body, to your brain during an exam, down to your toes when you are running. So it's generating a lot of electricity and a lot of muscle power there. So the QRS is going to be your ventricular contraction. The T wave, this after wave right here, that is going to be your ventricle repolarization. So I want to talk about something, these terms depolarize and repolarize. Let me add those to my notes real quick. All right, so we're going to resume here. So I added a little note here. When we think of depolarization, to me, depolarizing sounds like a relaxing word, but it is not a relaxing word. Depolarization is the term for when the heart is contracting. So P wave, that is the depolarization of the atrium. QRS is the depolarization of the ventricle. The T wave is the repolarization of the ventricle. All right, so that's the regeneration of the electricity. I don't know if you notice, I drew like little squiggle lines and an arrow going in so that it looks like, something's being contracted in on. Depolarization equals contraction. Repolarization is that process where the energy is kind of resetting in the heart and getting ready for the next beat. Okay, so QRS, P wave, T wave. You need to commit those to memory. What is happening in each of those? Remember that when we're talking about depolarization, we're talking about the heart contracting. We're talking about repolarization. We're talking about the heart renewing energy. Okay. There's times that you have to memorize on an EKG. Okay. So down here, you're going to see this little box that I made. I wrote this out on grid paper, so it kind of made it quite easy to draw one of these. When you're looking at EKG paper, you'll notice there's these little tiny, tiny, tiny boxes, and then there are bigger boxes. Okay, so what I'm talking about is right here. You can see on this real EKG, here is a very blown up version of it. But if you were to zoom in, what I'm talking about is this. This is a big box. This is a blown up version of it. Within this big box right here are 5 tiny, tiny boxes. You would have to really zoom in. There's 5 of those. It's 5 wide and 5 tall, as squares are meant to be. 5 and 5 make this big box. Each of those tiny, tiny, tiny squares represents 0.04 seconds. Okay? 0.04 plus 0.04 equals 0.08. That's going to equal 0.12. That's going to equal 0.16. And that's going to equal 0.2. So all 5 tiny boxes are going to equal that's hard to do on a camera. That's going to be 0.2. That tiny, tiny box is 0.2 seconds. That tiny, tiny box is 0.2 seconds. Okay. All right. So as we're looking at these, you need to memorize a few things. A QRS should be 0.06 to 0.1 seconds. So it should be about 1.5 to 2.5, 1.5 of these tiny, tiny boxes, or half of this larger box. So your QRS should never be more than this side of that. Does that make sense? Your QRS is 0.06 to 0.1 seconds. The whole big box, aka this little guy right here, is 0.02. So this waveform right here, the QRS complex, should never be more than half of one of these. All right? So you have to commit this to memory. It is in your review questions. 0.06 to 0.1 seconds. It should be skinny, like this. This is a bad drawing, but it's there, right? Not fat. This is how the bad tattoos of the world are drawn, but that's not what we want our QRS to look like. Okay. Your PR interval. The PR interval that you can see that I'm talking about is from the beginning of the P wave to the R. Now, in a QRS, it goes like this. It goes Q, beginning, R, S. Q, I need a different pen. Q is down here, R, and S. Okay? So, the PR interval is 0.12 to 0.2 seconds. So basically, if you see from the beginning of the P wave to the top of the R wave being bigger than one of these squares right here, you got a problem, okay? You've got a conduction defect. So, two things to memorize. QRS, 0.06 to 0.1. PR, 0.12 to 0.2. Just remember, I think it's easiest to just remember the PR should be the same size. It should never be bigger than one of those little boxes. All right. When we're talking about mapping out the times on an EKG, what you need to know is 5 of these is 1 second, right? So 5 times 0.2 equals 1 second. So if I'm looking at an EKG and I'm trying to map something out, I got 1, 2, 3, 4, 5 of these. And I'm going to draw where I started and draw what I end. That is 1 second. Okay? 1 second. So in this 1 second of this particular one, we just have one QRS complex there. All right? So 5 of those big boxes, I say big with a grain of salt because there's tiny, tiny boxes and then there's a little bit bigger boxes, are 1 second. So 5 tiny equals 0.2 and 5 big equals 1 second. All right? Now let's talk about voltage. That's the time frame that we're looking at. Voltage. That is how much electricity that we're generating. 2 of the big boxes is 1 millivolt. So if I'm looking at this QRS complex, right? Let's look at this one. At this general location in the V3 lead, I'm looking at someone's QRS complex. I'm looking, and this is just going to be a rough estimate. I'm not using, like, this is not going to be real, like, I'm not a cardiologist, you know, going in deep here. So 1, 2, 3, 4, about 5 big boxes. Every 2 boxes is 1 millivolt. So this is about 2.5 millivolts right here of electricity. It's about approximate. The thing that you need to just memorize on NCCT is that 2 of the big boxes is going to equal 1 millivolt. So that is just right up here with your math that you have to remember, or your just facts that you need to memorize up here about the QRS being 0.06 to 0.1 and the PR being 0.12 to 0.2. You've got to also memorize that 2 of the big boxes is going to be 1 millivolt. Okay? The next thing I want to teach y'all about is atrial fibrillation versus atrial flutter versus normal sinus rhythm. So I don't know if you remember the jumping jacks I made y'all do last year, where it was like your arms were the atrium and your legs were the ventricles, and y'all would do jumping jacks, and it would be like 1, 2, and you would go bop, 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 bop. It's a good way to demonstrate how they're working together. Atrial flutter. This is the way I came up with it. I don't know if I used this on you guys or I thought it up later. Atrial flutter, I want you to imagine you have a bunch of kids in a classroom, okay? The teacher is the AV node, okay? The SA node equals the SA, which equals the pacemaker of the heart. Okay. The teacher is your pacemaker node. Y'all have all been in a class where one kid just keeps interrupting. So I want you to think of atrial flutter as the one kid who just cannot stop talking during the class. They're going da 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 da. They are interrupting your teacher. They keep interrupting the teacher. They won't stop. What the result is in an EKG is we're going to get a sawtooth appearance. It's going to be regular. R to R interval. Boom, 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 boom. One kid is doing the talking. One spot in the atrium is misfiring, and it's creating this little, it's basically creating excess P waves. It's like instead of one P wave, you've got P wave, P wave, P wave, P wave, QRS, P wave, P wave, P wave, QRS. You're going to see a regular R to R. You're going to see like a little butterfly or sawtooth rhythm thing there. So, atrial flutter, fluttering of wings, when you think of a bird, fluttering, or a butterfly that's fluttering its wings, it's uniform, right? It's going the same thing over and over. Can y'all see me talking with my hands in the shadows? The butterfly flaps its wings the same way every time. Okay, in atrial fibrillation, many spots are misfiring. It's not just one doing the problem. Many, many, many spots are misfiring. So I want you to think of it. This is the class where the SA, the pacemaker, the teacher, has no control, and everybody's adding in their 10 cents. Everybody's putting their words in. And so what you see is there's no uniformity here. It's just this like low level of okay? They're fine waves. They're irregular. If you look over here at our R to R, up here we had a nice regular R to R. We just had one troublemaker. Now we've got innumerable troublemakers, and so we've got an irregular R to R, okay? This is going to look junkier and uglier on a rhythm. It's not going to be regular. And with atrial fibrillation, the big critical thinking connection I need y'all to make is when we're thinking of AFib, we always have to think of clots. And clots always make us think of anticoagulation. So you can do a really great level 3 thing, and you could say your patient has atrial fibrillation, and say we're talking about phlebotomy. What lab do you expect them to get drawn, or what color top? And you could go all the way to atrial fibrillation. I'm always thinking about clots. Clots always make me think of anticoagulation. Anticoagulation, well, what are we testing for with, that's going to be our blue tops with sodium citrate, PTT. Do you see how that's a line that I want you to be able to draw in your mind of like where to go with atrial fibrillation?